Hello students, how are you? And you're done with your module 1, which is about factoring polynomials. Now, we'll go on to another topic, but still we're going to use factoring polynomials, which is rational algebraic expression. But before that, let me review this. Okay, say for example, you have your 2 and another number 3. Okay. If we're going to write this into fraction form, 2 over 3, we call this as rational number. Okay? But now, let us add 2 with 2x squared. Okay, 2x squared is a monomial, which is also a polynomial. And you have your 3. Let's add that 3x plus 1. So, 2x squared is not a rational number anymore, but it is an algebraic expression. So, when you see algebraic expression that composes variables or constants or coefficients. So this 2x squared is already an algebraic expression. So, I have here another, you have here 3x plus 1. So 3x plus 1, this composes two terms. That means to say this is binomial, which is also a polynomial. So with regards with this, so you have here the ratio of 2x squared and 3x plus 1. So for example, you have here the numerator is 2x squared. This over the denominator, which is 3x plus 1. So since we're dealing here with algebraic expressions, so we're now going to call this 2x squared over 3x plus 1 a rational algebraic expression. Okay? Okay. So what are you going to remember when you talk about rational algebraic expression, or we're going to denote that or abbreviate that as RAE, rational algebraic expression. So the D here, the denominator, must not equal to 0. Why? Okay, say for example, you have your 2 over 0. So 2 over 0, that is actually undefined. So we cannot consider 2 over 0 a rational number, but it's undefined. So the same thing, if you have a rational algebraic, an algebraic expression that is over 0 or divided by 0, that is undefined. So that is not considered as rational algebraic expression. Okay, how about this? Okay, 3x plus 1 only. Can we consider this a rational algebraic expression? Okay. Yes, that can be, because that can be expressed into n over d. How? That would be 3x plus 1 over 1. So we have here 3x plus 1. So when I see here over, this is the horizontal line here is the over, or we can say it as divided by. So 3x plus 1 all over or divided by 1, that is still 3x plus 1. So meaning 3x plus 1, though we could not see a denominator, but still can be expressed into a rational algebraic expression. So that is an RAE, rational algebraic expressions. Okay. Now, let's have how to simplify algebraic expression. Simplify the following rational algebraic expression. Okay? Okay. But let me give you a rational number first. We're going to simplify a rational number first so that it's easy for you to deal with algebraic expressions later. So you have your 16 over 24. So in your elementary, as you remember, so in simplifying a fraction or a rational number, you look for the GCF or the greatest common factor. So 16 and 24, so you need to master the GCF lesson or topic. The GCF here is, of course, 8. So after that, so you divide each number with 8. So 16 divided by 8, that is 2. 24 divided by 8, that is 3. So that is how to simplify in elementary way. But since you are now in high school, okay, this is how to simplify in a shortcut or an easier way. Okay, the same thing, you look for their GCF. Okay, so you look for their GCF. GCF is still 8. So this is it. 16 divided by 8. So when you crush it, that means to say you divided it to a GCF. 16 divided by 8, that is 2. 24 divided by 8, that is 3. Okay. So meaning 16 and 24 are being crushed, or you cannot say it's eliminated. Meaning the remaining numbers here, the 2 and 3, just copy it. So that is 2 over 3. Okay, that's it in high school way. Okay, this example is a rational number. How about if I'm going to give you a rational algebraic expressions? Okay, take a look for this. Okay, 14x squared and over 28x. Okay. The same thing, you look for their GCF. So since they're both monomial, the numerator and denominator, that's very easy to look for their GCF. Or since you're dealing here with algebraic expressions, so we're not going to call it as GCF. We will call that as GCMF, greatest common monomial factor. So you start with 14 and 28. So 14 and 28, their common is, of course, 14. Okay. 14 divided by 14, that is 1. 28 divided by 14, that is 2. Now, how about the x squared and x? Okay, their GCMF is, of course, x. As I gave you, the tip is to just pick the variable was the least exponent. That would be your GCMF. So here, x squared divided by x is x. Then you have your x divided by x, that's 1. Now, let's proceed. So you multiply the remaining numbers or expressions. So you have your 1 times x, that is of course x. 2 times 1, that is 2. Okay, that's it. So the simplified form of 14x squared over 28x is x over 2. Now, let's have another example. Number 3. You have your v squared minus 49 over 2v minus 14. Okay, at this juncture, you are not, you involve here two terms or binomial. Numerator and denominator are not monomial, so we cannot use GCMF here. But sometimes you can use it if it is necessary. So you have your v squared minus 49. Okay, class, here we are. We're going to use our lesson, or yes, our learning about the factoring polynomials. So you should master all the techniques in factoring. So v squared minus 49, as you can see, this is difference of two squares. Okay, v squared minus 49 over 2v minus 14. Let's have third example. Okay, observe 75t cubed plus 30t squared plus 3t. First term, that is not a perfect square. Third term, 3t, that's not also a perfect square. But notice, common t, one factor t. 75, 33, they have also common factor. So the same with number 2 example, meaning they have GCMF. So that would be 3t. Okay, and then you divide each term by 3t. 75t cubed over 3t plus 30t squared divided by 3t plus 3t divided by 3t. Okay. So you have 3t. 75 divided by 3, that is 25. T cubed divided t, that's t squared. And then 30 divided 3, that's 10. T squared divided t, that's t. And then plus 3t divided by 3t is 1. Okay. Let's clear this one. Okay. Okay. Next. So let's check here if this 25t squared plus 10t plus 1 is a perfect square trinomial. So check if the first term is a perfect square, 25t squared. Okay, that is a perfect square. 1 also a perfect square. Okay, it's clear. Express each term to the power of 2. So that would be 5t quantity squared for 25t squared. And then, okay, plus square of 1, that is 1 squared. Okay, you can do this directly, class. So you have your, again, when you have PST times 2. So, just multiply the base or the square root of each term. 5t times 1. Okay. So, as you observe, 2 times 5t times 1 is 10t. So, clear that this is a perfect square trinomial. So, since it's perfect square trinomial, you do like this directly. Get the base of first term, that's 5t. And then base for here, 1. Okay. Again, when you say base, that must be expressed to the power of 2. Okay? That's it. Okay. Again, reminder, you can check if your answers or solution is correct by multiplying or by getting the product. And you get the trinomial or the given trinomial. Okay, that's all for the factoring polynomials. For more questions, or you can ask me directly. Okay, you can comment here on this video. And don't forget to subscribe. Okay, stay up for more video lessons. God bless you.